Okay, welcome to the meeting. So my name is Eric Mwangi. I am the AI ML lead. So our topic for today, we are going to go through the end-to-end machine learning workflow. So based on my research, I realized that majority of us do not have experience with AI or machine learning. So for our sessions, we'll start from the very basic things. So for today, I'm going to be introducing you through the workflow, what the machine learning engineer does, and also the tools that we're going to be using. So first I'll go through some slides and then I'll take you through a project so you will see it firsthand, so that from next week, God willing, the speaker who I invited will be teaching us from EDA, exploratory data analysis, that's NumPy, Matplotlib, and Pandas. And then from there we can go through TensorFlow and other stuff. So welcome, and if you have any question, you can feel free to ask.
Just looking back, looking.
Okay, so what is machine learning? Machine learning is a subset of artificial intelligence that enables systems to learn from data and improve over time. So in basic programming, a programmer usually has to explicit, explicit, eh, sorry, explicitly write the program so that the computer can run it. But as you can see, sometimes projects can be very complex. You'll need the program you write will not be enough for the machine to capture everything. So this is where machine learning comes to help. So instead of you writing explicitly, the program will be learning the patterns on its own. So it's like teaching a computer to make decisions based on patterns rather than explicit programming. So for example, you can be creating, you might want to create a program that is able to identify human faces. But as you can see, if you are to give the instructions yourself, maybe you could have said something like, you should look for the eyes, the nose, or the mouth. But you can see that it might not be enough for the computer to understand. But using machine learning, you'll be feeding the program with a lot of data, a lot of images of people, and it will be identifying patterns on its own. So the next time you provide it with an image of a person, it will be able to identify. So that's an example of machine learning. And now the machine learning process, mostly it entails data collection, data preparation, model training, evaluation, and deployment. So as I said earlier, for you to train the machine learning model, you need to have a lot of data. And so the first step is usually data collection. You need to get data for the specific purpose that you have. So if you are trying to create a machine learning model that is going to predict whether a person has cancer, you'll need that type of data that will have the data of people who tested positive for cancer and those who do not have cancer. You need to have both sides, you should not be biased. And then data preparation, model training, and deployment, that's what we're going to go through. So maybe you can go to the next slide. So step one for data collection, you start by relevant data that represents the problem you want to solve. So you can get this data from databases, APIs, or even surveys. Quality data is key to a successful model. So if you're working for a company and they ask you to create a machine learning model for them, you might be lucky enough to find them that they have a database of the data that is required. Or if you are to create a model that is going to predict what people are going to buy, maybe in a specific season like summer or winter, you can access the API like Amazon API so that you see what people are buying during those periods, and you'll get that data and train the model with it. Or you might even collect the data yourself through surveys and other methods of data collection. But mostly, we usually get data from a website called Kaggle. Kaggle is a website which hosts data sets for majority of the things that you're going to need. So I walk you through the project, you'll see the dataset I'm going to use is from Kaggle. So I'll also walk you through that interface. And then the next step after you've collected data is for you to prepare the data. So before training, you should clean and pre-process your data. So this involves processes like filling missing values, normalization, and feature selection. So for filling missing values, you see the data is collected by people. There might be some errors. So when they're filling data, they might not fill in all values, or when collecting data, not all values might be available. So you can handle that by either deleting completely, or there are other means that you can handle the missing values. Then normalization, this is just a way of scaling data. You know, a machine learning model works better with data that is scaled down, not a higher value. So for example, you had data of students in a class and you're recording their ages. So let's say hypothetically their ages from 1 to 100. You see that value is high. So for a machine learning model works better with normalized data, which it's scaled down. So from 0 to 100, you can scale it down to 0 to 1, but the difference is still there. So that's what we call normalization. And feature selection, this is after, okay, when you're training a model, it's usually a repetitive process. So you can finish training for the first round, and then you'll see maybe the model is quite good. You will see the most important features and the features that do not contribute a lot to the outcome of the model. So when you see the most important features and those that did not contribute more, you can remove those features that do not contribute to the model bit more. So proper preparation ensures your model learns effectively from the data. So data preparation, when creating a model, this is the most important part. Because if you mess up your data, your model can provide inaccurate results. And sometimes it's very risky because let's say you're creating that model to predict whether a person has cancer and you mess up your data. And then let's say a hospital uses your model and it predicts that someone who does not have cancer, it predicts that that person has it. So you see that's critical. So the most important part in training a model is the data. You should make sure your data is well prepared. And then now after you prepared your data, that's when you train your model. So you have to choose the right algorithm. So there are different algorithms for different tasks that you have. So you can have tasks like regression or classification. Okay, we have not gone through that, but those two tasks, they have different algorithms that solve their issues, their problems. So you have to choose the right algorithm based on that problem that you have. And then this is where the magic happens. The model learns to recognize patterns and makes prediction based on the input data. Okay. After you have trained your model, you evaluate it. So after training, it's time to evaluate your model's performance. You use metrics like accuracy, precision, and recall, or others like mean absolute error and mean square error. So it helps you to assess how your model performs. So it also helps you to identify areas for improvement. As I said, that this is a repetitive process. So you have to identify areas of improvement. If your model has not performed well, then you go back to the first step or anywhere you see you have messed, maybe you have used a wrong algorithm or things like that. After you have finished training your model and it is performed well, you can now deploy it. You can deploy it so that you can use it in an app or website or any other platform. Or maybe you can just save it somewhere else. You can use it another time when you want to make predictions from it. Okay, maybe I can now show you these tools. So for data preparation, we use NumPy, Matplotlib, and Pandas. So NumPy is a scientific library for doing mathematical calculations. So this one is an alternative to a Python list. It is faster because it is implemented in C, so it runs calculations faster, much more faster. And Matplotlib is for plotting your data. So you want to draw inference from the data. So the data you have collected, you need to understand it better. So Matplotlib really comes to help because some data might be complex to understand, but when you make plots with it, it becomes easy. And also Pandas, it also helps you to view your data well. Data can be stored in C format. It can read data from CSV format or Excel and many other formats. So this step for data preparation is what we call EDA, exploratory data analysis. So you explore your data so you can analyze it and draw inference from it. So at least you can understand it well before you train your model. So for model training, you also have tools like TensorFlow, scikit-learn, and PyTorch. So we have said that when you're training a model, you have to choose an algorithm. So TensorFlow and scikit-learn and PyTorch, they have algorithms fitted into them. Okay, they're like abstracted in some way. So it makes it easier for you to use the algorithm instead of you writing it from scratch. The algorithm is already there. And it also has other functionalities that makes your work easy. These are the tools you're going to be interacting with mostly. So maybe I can open Kaggle so you see it. Let me share the screen. Anyone was a question up until that point? Yeah, ask. Yeah, majority of the data set is inakwanga saved in CSV format. So you can save it. Yeah, yeah, yeah. Uh-huh. Oh, data set you gonna roll. Yeah, yeah. Okay. No, CSV ni comma separated values, so you can just input it directly, but you can interact na nini pandas. Pandas makes it much easier. Okay, I can nikifungua project tutaona pandas inafanya easier. Is there any other question? Okay, let me open Colab. So this is Google Colab. It also functions like a Jupyter environment, and you're also provided with a GPU and a TPU. So as you can see here, in the runtime, you can be provided with a CPU, a GPU, or a TPU in case you want to run a model which requires a lot of data. So this is where personally I like using Google Colab more than Kaggle because it's connected better to my drive than I find Kaggle to be more difficult than Colab. But my dataset I get them from Kaggle and I import it to Colab. So maybe I can take you through this project. So the packages that we are using, it's Python. So I have to say first that we have not learned this. So don't be stressed if you don't understand what the code does. But all I want you for you to see is that the workflow, how the workflow is implemented. So that from next week, let's say when you're saying you are studying NumPy or Pandas, at least we'll know why you are studying it. It's not that you studied and you don't know how you're going to use it. So that's what I wanted to do for this session. So we are going to import those packages. Imported pandas, NumPy, TensorFlow, Matplotlib, and Seaborn. Seaborn is almost like Matplotlib, but it creates better plots than Matplotlib, and it is better for designing the style of the plot. Wherein I've imported those packages. Then now we're going to work on the medical cost personal dataset. So this is a dataset from Kaggle. So the task is to train a model to predict a person's spending on healthcare based on the number of features like age, sex, BMI, body mass index, the number of children that person has, the whether that person is a smoker, and the region that person is coming from. So I had already downloaded the dataset from Kaggle. and it is saved in my drive. Insurance CSV, it is in CSV format. So if I import that data, I'm using pandas because I imported it as PD. As you can see, pandas makes it easier to view the CSV dataset. If you were to open it in another environment, maybe you cannot understand how the dataset is arranged. So pandas makes it easier for you to understand the dataset. And also another thing about Colab, it can generate plots for you so that you can understand your data better. So for example, I didn't have to write code to generate these plots. So this is one advantage of Colab. So maybe you can use that first one as an example. This is a plot of the age. You can see you have the age column in the dataset. So from this plot, maybe you can infer that majority of the people, you see they are over 160. They are between the age of, let's say, 15 to 20. So that's how it can help you to understand your data better. So this is what we call exploratory data analysis, EDA. I also went ahead to write code to visualize the number of male and female subjects in their data set and the number of people who are smokers and non-smokers. So as you can see, there are columns in our data set, whether that person is a smoker or the sex, male or female. You can see it's almost balanced. So that is a good thing for a model because if it was imbalanced, then the model will have a bias. So let's say if men were much more than women, in making predictions, it will be more biased to the males. So that's an advantage of having a balanced data set. And then the people who are smokers, majority are not smokers, as you can see, and very few smoke. And then another process of EDA, we said you should check whether there is any missing data and handle it based on the findings. So luckily for us, the data set was well put. There is no missing data from all the columns. So all the columns are full. There's no missing data. Then for a model, a model cannot understand data is in text format. So you usually have to convert it to numeric. There's something we call one hot encoder. It's used to convert data into numeric format. So as you can see, the sex, female or male, it has been converted to numeric format 1 or 0. Smoker, no or yes. If you go back, it was in text format, now it has been converted to numerical format. So a model does not learn on text data, usually learn on numeric data. So the next step after you have done your EDA is you split your data. You usually have to split your data into X values, X and Y. So X are the features. So features are the characteristics that you want the model to learn. So that is age, BM, children, smoker, all of these things. And then the Y, it is the value that you are trying to predict. So for now we have our y. So it will learn the pattern between the y and x. So the next time when you're providing data that does not have the true label, which is charges, it will be able to predict it. So I created the x and y variables. You can see the x, it's all the values without the charges, without charge column. And the y, it's charges alone. And then now, after splitting into x and y, you change it, you have to split further into training and testing data. This is because when you are training a model, you have to set part of the data set aside so that in the training data, that's what it's going to learn from. And when you are testing it, you want to test it from data that it has not seen. Because when you train on the data, it might learn the data too perfectly. And when you test it, it might seem to be more accurate. But if you bring data it has not seen, it will be wrong, which is not good. So you have to split to training and testing data so that it learns on a different data set and tests on a different data set so that its prediction or the evaluation, whether it's accuracy, it will be correct. So the X we split it into training and testing data. Also for the Y, training and testing data. And most of the time, we usually split it by 20%. So the training data is 80% of the data set, and the testing data is 20% of the data set. Then now, you convert it to tensors. So here we are using a neural network as the algorithm. So for neural network, it has to convert it to tensor because we are using TensorFlow. Okay, so this is the architecture of a neural network. Usually has an input layer. This is where you input your data, and then it usually has hidden layers and an output layer. This is where it spits out its prediction. Okay, I can give you the visualization of how a neural network learns before we go ahead. So it's same as the image I just showed you. It has an input layer. All of these are hidden layers and an output layer. For this website, it doesn't show an output layer, but there is an output layer. So you can give it a task to, this is like a Cartesian plane. When you give it coordinates, you can give it a task to predict whether that is either a blue dot or an orange dot. But for it to be able to predict, it must like draw a boundary between these two so that it knows that if it is outside the boundary, it's orange. If it is within the boundary, it's blue. And then these are the hyperparameters that are used in a neural network. Maybe we start running it. You can see it slowly learns from the data it has been given. Immediately, it has already started creating a boundary. So the next time you provide it with a coordinate, whether if it appears somewhere like here, it will be able to predict whether it will be able to predict that it is orange in color. And if it appears here, it will be predicting that it is blue in color. So that's a visualization of how a neural network learns. So building the model of a neural network. So use TensorFlow with Keras API. And then in between, you have the layers. So for my model, it has two layers with 100 nodes. So you can see this one, it has 5 of them, but for mine, it has 100. And then the next one, it has 10. And the output layer, it only has one because you only need one output. Then we compile the model. Compiling a model, you have to give it a loss. You have to give it a function in which it will tell you how wrong your model is. So that's the loss function. And then the optimizer, it helps the model to reduce the loss. So based on what your loss is, the optimizer will help your model to reduce it. And then the metrics, this is when you are evaluating your model. You can have, for example, here using a mean absolute error. You can also have accuracy as a metric. So this is how it will be performing. It will be measuring how your model performs. And then this model.fit function, it's like telling your model now it can learn from this data. We said it is learning from the training data. So X train and Y train. And then the epochs means that the model has a chance to view the data. For example, here we're using 300, so it has a chance to view the data 300 times. So the model trains, you can see its loss and the mean absolute error. So it's reducing, which means it's a good sign. And then now after it has finished training, the final error was that 5.68 and the loss was that 5.68. So the loss function was a mean absolute error. So that's why it's the same thing. Then you evaluate it on the test dataset. You see the loss after evaluation is actually lower, which means the model is performing great. So after seeing something like this, maybe you want to improve it. Maybe that 179 is a higher loss. You can repeat it continuously until you have a loss that is acceptable, because most of the times you cannot achieve 100% accuracy in the model. So you have to have a loss that is at least acceptable in the scenario that you are in. Now maybe you can plot the loss and metric curve. It's using the same function, mean absolute error, that's why it's only one. But as you can see, the loss is reducing, which is a good sign that the model is actually learning. Then after you are satisfied with your model, you can now save it and use it somewhere else. Okay, I'm not running the other, that is providing an error. But that's just the basic work or overview of what a machine learning engineer does. So maybe if you have any other question. Moko sawa?
and niko sawa, niko sawa.
Yeah, so basically on your overview.
But machine learning inakaa tu ngumu ski.
Hmm?
Machine learning seems a little hard.
Actually, si ngumu vile,
Mhm.
but as in ukizoea si ngumu vile. It's actually not hard. Ni vile
Alafu
eh,
kuna vile like msi anaweza deploy dataset
eh,
peke yake,
eh,
alafu atengeneze API key sa aitumie kwa a small project.
dataset peke yake.
Eh,
Actually, maybe tuulize Alex. I don't know. Sijakaa across. Maybe Alex ako aware. sababu yeye anakuanga hizo sekta za API sana.
Alafu nikifanya hapa hivi kwa umesema inaitwa ni collab,
Eh,
like sihitaji hizo nini, sihitaji hiyo heavy infrastructure kwa mashine yangu.
yeah, but collab ina run Python peke yake,
Aha.
so utahitaji heavy infrastructure, but unaona kupata access sasa ya CPU na GPU sababu unaona ni free, utaipata most of the time, so the time yenye unatumia iko limited, so maybe ulipie sasa a pro version utapata throughout, but until then unatumia for a moderated time.
Ndio hiyo inabamba. Niko na unit ya machine learning na AI next sem.
Eh,
At least sitaingia nikiwa chest.
actually nitatuma resources, kuna
Sawa sawa.
nilikuwa nisha after this yani mimi mwenyewe natumia, actually si mimi hata ni first year.
Mimi niko naingia mwaka wa 3.
Oh,
Yeah.
so after hiyo I think mmaliza, maybe you can end the meeting.
Sawa sawa. Thanks.
Poa.
Poa.